Okay, so today we're going to deal with TG7, which is what we want to, we're going to do examples for, if we look at a graph, being able to write the equation. Now these can be a bit challenging at times, so I'm going to walk through both these two examples and then a couple more, just to make sure that we have a good understanding of how they work. Most of the steps are pretty easy. The only one that's kind of difficult is the phase shift, but we'll talk about that when we get to it. So what we have is we have a graph. Now this graph could be either cosine or sine. And so we're going to talk about both of them because we could write it in terms of both. So we're going to look at number 31 first. The directions up here, this is just like from your homework that you'll have tonight. It just states, it just tells you what you're supposed to do. So the very first thing we're going to do is do the cosine function first, because that one's the easier one for this. It doesn't matter whether you do A or B first, but this is cosine function first. First of all, it's very obvious that it's reflective, right? So cosine function should naturally run like that. So it's reflected over it. So we know that we're going to have a negative in front of our function. We're going to obviously base it off of this. Okay, my amplitude is how far up and down it's going. You'll notice it's 12 to negative 12, so my amplitude is 12. Now I'm going to write the cosine. Now comes the tricky part, right? B plus C inside and then plus D on the other side. So let's talk really quickly about the D. Okay, if it's a D, as if it's a vertical shift up and down, this is not. This is simply a stretch. There's no moving it across the, moving it up and down. So we don't need to worry about the D. So the only thing we have to worry about is a B and a C. Now, C has to do with my phase shift. So I want to quickly talk about this for a moment. You'll notice that it's not shifted at all. Okay, a phase shift would mean I would have, the pieces would be off. So there's no phase shift. So I don't have to worry about C. The only thing I have to worry about is B. Now, B is equal to, so the period, okay, is equal to 2 pi over B. And so I'm going to look really quick to talk about what our period is. You'll notice the period is pi over 5. Okay, so our period is pi over 5, which is this equal to 2 pi over B. And now I'm simply going to solve for B. These ones are the most challenging to find because you have to look at it and figure out what it's doing. You notice this is a full cycle of the cosine function. So that's what you're looking for, is where's my, do I have a full cycle? This is a full cycle of the cosine function, so the period is obviously pi over 5. So we're going to solve for B, so I have pi B equals 10 pi divided by pi, B equals 10. So my function is, okay, negative 12 cosine 10 t. So that's the easy one. Sine was a little bit more difficult. So if we're looking at this function as a sine, sorry, I'm looking at my notes. Okay. So if we're looking at a function as sine, I'm going to erase what I have right now. Okay. This one actually does have a phase shift. Okay. So sine functions would run like this. Oops, went too far. I'm going to use a different color too. Sine function would typically run like that. Okay, so that would be your typical sine function. So you'll notice that it did shift slightly. It starts at negative 1. So it actually shifted. I didn't think about how it shifts. It actually shifted, if you were to continue this way, it shifted 1/4 of a unit over. Now this is the hard part, and this is the part I want to make sure that we get. So when you have a sine function, it's split up into 4 pieces. There's pi over 2, pi, 3 pi over 2, and 2 pi. But I want you to think about when it shifts. If it shifts, so it's actually it's divided into 4s. So if we were to shift it by a half, I would start at pi. Okay? So, but if I shift it by a 4th, I'm starting at pi over 2. So I don't want you to think, because this is really hard to see with the pi over 5, I want you to think of the phase shift as 1/4. I shifted it 1/4 of a phase. All right? So when we look at our phase shift, that's how I want you to look at it, as 1/4 of the phase. So to find this phase shift is 1/4 because I shifted it 1/4 per unit. So to find my C value, I have to say, okay, it's 1/4 of what? It's 1/4 of what? It's 1/4 of pi over 5. So my phase shift is pi over 20. All right. The B value in this, is the same as the other one. So this is going to be the phase shift. To find my C value, it's equal to negative C over 10, because 10 is my V value. Remember that a phase shift is equal to negative C over B. Okay. So I'm going to multiply both sides by 10. So I have 10 pi over 20 equals negative C. So it's a negative pi over 2. So if I'm writing a sign function, we're going to put our A amplitude stays exactly the same. It also is not flipped, okay, it's simply shifted. So our amplitude is going to be a positive 12. Okay, sine, okay, 10t, this is the same as the other one, right, minus pi over 2, there's my C value, okay, plus d, and of course d in this case is 0, so that is my function. Okay, I know these are a little bit challenging. Again, the phase shifting, I think, is where is the hardest part. So let's move on to number 32. I'm actually going to need to scroll down a little bit. At 32, the sine function is actually easier. So in this case, you'll notice that its amplitude is 18. That's fairly easy. So the amplitude is 18. We're going to do the sine first. A sine B t plus C plus D. All right, so the amplitude is 18. The period is 2. So it's not 2 pi, it's 2. This makes an interesting. The period equals 2. So 2 equals 2 pi over B. So 2b equals 2 pi. So b equals pi. All right, so I have my A and I have my B. As far as phase shifting goes, there is no phase shifting. It has not, for the sine function, it has not shifted at all. It's starting and ending in the same place. So my answer for this one is going to be 18 sine pi t. Okay, and then obviously it's not shifted up or down. So this is my sine function. Cosine is a little bit more challenging. Okay, remember again that it is in groups of 4. So hold on just a moment. So my cosine, A cosine B t plus C plus D. Okay, now cosine would start like this. Okay, so it's also, if you were to continue this way, it's shifted. Notice 1/4 of a unit. Okay, so it's 1/4. 2 equals 1/2. All right, so this is my, so 1/4 of 2 because my period is 2, so it's 1/4 of that. So it's 1/2. So 1/2 is going to equal negative C over, okay, remember we found our B value on the last one, it was pi. All right, so we get pi over 2 equals negative C, so C equals negative pi over 2. So my amplitude stays the same. Okay, again, you'll notice that there is no flipping. Okay, I simply shifted. So it's 18 cosine, my B value is pi, minus pi over 2, plus D. Okay, and under homogeneity, you're going to have to create these equations. And I know this may be a little challenging, but I think you're up for it. Okay, I think you'll be just fine with them. So we're going to do one more example, actually 2 more examples. This one gives me an equation that wants me to sketch it. All right, so this, I should have probably drawn a better graph here. So I'm just going to say, okay, first of all, we know it's a sine function. The only thing that's different on this is this is a -3. This is a fairly easy function to sketch. My period is still going to be 2 pi, all right? My amplitude is going to change from 3 and -3, right? And I'm going to, let me make this down just a little bit so that it's more accurate. And I'm going to start down because I inverted because of the negative. So that's my picture. All right, let's graph one more. This one, I wanted to do one easy and one hard graphing. All right, now this one also, the directions, again, I wanted to put the directions that were in your homework so that you were familiar with them. It says graph the function over the interval 0 to 2 pi and determine the location of all the local maxima and minima, okay? Meaning that there are maximum and minimum points, you need to find those in this type of a problem. So, the very first thing I want to talk about is the fact that it shifted pi over 3 units to the right. So this is a little bit harder than if we were just doing if we were doing halves and fourths, because those work nicely. So what I want you to think about the fact that we have pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so if we're going to shift it 1/3 of a unit to the right, we're simply going to add pi over 3 to each of our spots. All right, so pi over 2 plus 3, and I did this math before, so I have them all written down, but I'll just do this one with you. So pi over 2 is 3 pi over 6 plus pi over 3, which is 2 pi over 6. So this is going to be 5 pi over 6. So we're going to shift this to 5 pi over 6. I'm going to write these in different colors. Okay. So we're going to shift it 1/3 of a unit to 5 pi over 6. Okay, then the next one that we have is going to be 4 pi over 3. Okay, again, all I'm doing is adding pi over 3. I've already done the math. And then I don't think I did this though. I didn't do this one, so I don't know the number for that one. But the very last one is going to be 9 pi over 3. So all I did was shift it pi over 3 units. Now the next thing that's going to happen is we're going to have a vertical stretch. The other thing I want to talk about is that it's going to start not at 0, but at pi over 3. So we're going to have a vertical stretch of 1/2. So if this is 1, we're going to go 1/2 here. Okay. 1/2. Okay. So it's going to be smaller. And that's it. That's the only changes that we have. So we're going to start here. And we're going to go. Sorry guys, I messed up. Okay, I hope this doesn't screw you up too bad. We gotta go this far, there we go. Alright, making sure I only go to the half points on both of them. And that's the graph. So you should be able to graph these. Some of them are going to be a little challenging. They don't have to be perfect. They don't have to be perfect on graphs. I just want to see the shifts. So have fun with your work. If you want to check your work with graphing calculators, that's fine. I would like to see some of the work though behind it so you understand the where it's coming from. And I forgot, sorry, maximum, minimum. Okay? Maximums are at 1/2. Minimums are at -1/2, right? And what's the x value? Okay, so the x value for this one is 5 pi over 6, and we'll go ahead and find this one since I didn't do it before. 3 pi over 2 is the same thing as 6 pi over, if I multiply by 3, 6 pi over, I want this to be 3 pi over 2, pi over 3, 2 pi over 6. I'm making this 6, I'm multiplying 3, 9 pi over 6. Plus that is 11 pi over 6. So the x value for my -1/2 here is 11 pi over 6. That's it, I promise I'm done.